Today we will start with rehabilitation engineering. People call it different names: rehabilitation engineering, assistive technology. You can replace one with the other, but I like to call it rehabilitation engineering because everybody now is calling it rehabilitation engineering. I will be talking about the clinical practices of rehabilitation engineering, some standards, and tissue integrity management. I will start with the clinical practices. The idea that we would like to do today is that everything we mentioned, we would like to think about what is the thing that we can do as engineers to help. The most important thing in engineering is solving problems and developing products and doing assessment and doing testing. And I want you to keep that in mind because a lot of biomedical engineers work in testing products. So we can develop an assistive technology product, but you need also to test it and make sure that it is reliable, robust, and safe. Let's start by quick definitions. Limb prosthesis, we're going to talk about upper and lower extremities, and we define them as an artificial replacement of any or all parts of the lower or upper extremities. It's a device that is designed to replace as much as possible the function and or appearance of a missing limb or a body part. This is different from artificial organs. Artificial organs are things that are internal, but prostheses that are outside the body, they're attached to the body, but they're upper and lower extremities. Functionality is superior to appearance, but because of the technologies that we have now, aesthetic prostheses are actually very desirable, especially for children. Remember the classes of the devices, the class 1, class 2, class 3. Class 1, it is not life-sustaining, not life-threatening. Class 2, not life-sustaining, but life-threatening if it fails. And the class 3, life-sustaining and life-threatening. What do you think most of prostheses will be? 2? Because if it fails, it could be life-threatening. What if it's the lower extremity and it broke and someone fall on the street or doing an activity practice? It could be it is life-threatening. It's not life-sustaining, we agree on that. But it's life-threatening if it fails. That's the key. What if I have an active prosthetic arm that is connected to the nerves, and then you can have an infection? That could be life-threatening. Now, let's say a wheelchair that is not fitted well. You're creating ulcers, and the subject is paralyzed. Let's say does not feel. That's life-threatening with the ulcers. So that's how we look at it. Yeah. Now, the purpose of prosthesis to provide an individual who has an amputated limb with the opportunity to perform functional tasks. So now here's the thing. There are two types of prosthesis. You can say that there's something that for a subject who has an amputation, and then you can have like someone with like a spinal cord injury. We don't have an amputation, but we're trying to develop something for the subject. The most important, we're going to focus on amputations here. That's my task in this lecture. Functionality is the most important thing, and walking, which may not be possible without the limb, that's an example of these things. And now I want you to remember when we talked about human motion analysis, that is part of physical therapy. Prosthetics are actually part of something called occupational therapy, which means that you would like to help the subject to perform a specific task or do a job with the limitations of the disability. Now, keep in mind, amputation, perform functional tasks. Those are our most important things. Prostheses may also be made for use during activities or sports, dancing, swimming, cycling, golfing, any of the other sports. And that's another. Also, we keep in mind that we're going to be focusing on people with amputations. That's the most important thing. And the last thing, the type of prosthesis used is determined largely by the extent of amputation. And who determined this? The physician. We come secondary. So after the surgery is completed, based on the clinical situation, then we get involved. So the extent of the amputation and the location of the missing extremity affects our job largely. It's very, very, very important for us. That's why if you want to work with prostheses, we need to have a good relationship with orthopedic surgeons. And those are our actually clients with physical therapists. We need to have an individual plan for each subject. And that's the collaboration between the surgeon, physical therapist, and the engineer. And then you come up with a plan, and then you give it to the healthcare insurance, and with outcomes, and everybody will be happy. Okay, how do you characterize success? And here, I want you to think about what can we do as engineers? What are the things that we can help in the, to achieve a successful prosthetic? Comfortable to wear. How would you characterize and assess comfort? Anything that you pressure the skin that can result in strain will lead to an ulcer. So comfort is actually something that we can measure by making sure that we don't have excess load or forces on the skin. And the tool that we use is a load cell. Remember the load cells that we used for the global engineering? These strips of load cells? Those are the things that you would like to put inside your device to assess continuously what is happening and if there is anything that is changing with time. And comfort is very important because it's related to pain. If the subject is feeling without a spinal cord injury. Okay, so assessing comfort, load, pressure, it's important. Now, easy to put and remove. Now, there is a debate between do we need to have larger number of parts or smaller number of parts in our prosthetic. Now, because we have the 3D printing capabilities, we're using more and more plastics in these prostheses, and they're made of smaller parts. If you are caring about functionality, you need more parts. If it's just aesthetic, less parts. But the subject needs to be trained, and the prosthetic needs to be easy to be used by the subject. And we are the ones who are going to train them alongside with the physical therapist. Lightweight, we agree on that. Plastics is becoming popular, and also fibers, carbon fibers, it's becoming a thing. Durable, how would we test durability? It's mechanical forces, but it would be using the fatigue testing, the cyclic loading. That will give you how much durable that is, especially their upper and lower extremities. So they're continuously getting loads. What do you think the most important mode or load? Yeah. Mode of loading would be for upper extremities, tension, lower extremities, compression. And that's how you do the testing for both of them, each one of them. Cosmetically pleasing, aesthetic, it's now becoming a thing. We need to be really considering a beautiful design. It's very important. We need to be, to empathize actually with the psychological situation of the subject. It's a very important thing. Really, it's really important. Because if they don't like it, they're not going to use it, and then everything will fail. Function well mechanically, and we are good in that. That's our field. And when you say function well mechanically, you need to look at the kinematics and kinetics, right? Parameters that we measure usually. And require only reasonable maintenance. That's another thing. Less parts, easier maintenance. More parts, harder maintenance. But if you have more parts, you can replace it cheaper. There's a lot of things that to consider. And when you do manufacturing and all of the other things. Depends on the motivation of the individual as well. If the individual is not motivated, we're going to fail. So it's very important to make sure that you empathize and understand the psychological situation of the subject. Here's one important aspect. You can't come to a subject immediately, let's say 3 or 4 months after they have the amputation, and to provide them with a prosthetic. There is a lot of psychological stages they go through until they get to the acceptance and trying to move forward. We cannot intervene at the beginning. It needs time. So that's why people do psychological therapy before actually doing physical therapy, and to build motivation. Because it could start with a shock, and then denial, and then you will have anger, and then you will reach acceptance. After the surgery, usually the stump will swell, and it will take months actually to go back to a shape that is stable. And that's why we have temporary prosthesis and then we have definite prosthesis. The definite one is the one after the stump is forming and shaping. And remember, the surgery also is another thing, because surgeons can do something called running sutures or separate sutures, and that affects the shape of the stump. And depending on where they get their training, and as engineers, we just deal with whatever we're getting from. But here's the good thing: if you do a medical degree and you become an orthopedic surgeon with biomedical engineering, oh, that's a big fit. That's an important fit. It's very good. Okay, consideration when choosing prosthetics. Amputation level, we're going to talk about the, let's say, anything that is on the joint, we call it articulation. So knee articulation or foot articulation. Anything in the, away from the joint, we can say that this is mid thigh or mid shaft, and we're going to talk about those more. This affects what kind of prosthetic you'll be using, the contour of the residual limb, the shape and the volume, and the suturing style, expected function of prosthesis. What do you want it to do? Do you want it just to do daily activity, or is it going to be experiencing heavy, let's say, activities like sports? And that affects the material and the design and everything. Cognitive function. How would you define a cognitive function of the subject? My understanding of it is that the level of education and the smoothness of them using technology, how easy for them to accept and use technology. We can't have a robotic arm and try to train someone that is, 8 years old to use the robotic arm. That'll be a big challenge for them. So the cognitive function is the mental state, right, or the educational state of the subject. Vocation of the patient. Is he or she doing a desk job or a manual? What are their daily activity that you would like to replace, and make sure that it's happening for them. Vocational interest of the patient, hobbies, cosmetic importance, and cosmetic importance is important because there's a lot of ethical issues with this. For example, I don't know if I mentioned this to you, but there was a case where someone who has an artificial arm in a party and shook hands with someone else, that guy got surprised and got a heart attack. And then they sued them because you need to tell people that you have a prosthetic arm. But yeah, keep that in mind. Whenever the closer to realistic prosthesis, there are other issues that we need to deal with. Okay, financial resources of the patient, and that's an important aspect. And I'm going to share with you a website that develop prosthetics. You can download the solid work, you can print it, the model, you can build it, and you can ship it to someone who actually needs a prosthetic arm, especially for kids. So again, in the United States, if you have an individual plan signed by the physical therapist and the engineer with specific outcomes, you can be reimbursed from your health insurance. Otherwise, you can't do that. Problems occur when using prosthetics are, the most important problem is poor fitting. And so poor fitting can cause problems for the subject. Unequal weight load will result in increased energy consumption when using the prosthetic. So the subject will always be tired, actually, and doing hard work to work it and to perform the daily activities. Now, this is dangerous because if the subject is not happy with it, not going to use it. So excess stress or pressure, that's another thing. So the first thing is the problem of energy consumption and using it. The second problem is you have pressure ulcers because of the unequal weights. And that's another, so this is a secondary complication. And it's important to understand in rehabilitation engineering, what's really dangerous is the secondary complications, not actually the main problem. Increased probability of pain, skin problems, skin breaks, And then we have infections, and we have another amputation. And that's actually common, that people will have multiple amputations because of the misuse or the poor fitting of the prosthetic at the beginning. Working with prosthesis takes extra energy. The stump should be checked every day. And that's another thing, that the physical therapist and the occupational therapist need to train the patient of how to check every day for any redness, blisters, soreness, swelling on the body. That's a daily activity. It's not, something that should be overlooked. Prostheses need to be adjusted several times before it fits well. And that's why we have temporary and permanent prosthesis before we do this. Now, how would you check for redness, blistering, soreness, and swelling? You can check physically, but I like to use technology. If I want to check for redness, the infrared cameras that we use to heat mapping. If the body there is redness in the body, it means there's a lot of blood circulating there. The temperature will go up. So you can actually do this. So if we can design a small device, something that you hold with your hand, and every time you do scanning on the that's a really good device. It does not exist yet, but using infrared coat, it'll be catching up with infrared because of COVID and the heat mapping of the faces. So now we have a lot of devices they don't use, so we can use them for medical application. That's a really cool thing too. So yeah, having these tools that can check for this be really awesome. So we have different steps how to manufacture. We are not in industrial engineering, but if you're in industrial engineering, we'll go deeper into all these steps. But if you have inpatient rehabilitation admission, which means that the subject is actually in the hospital, we measure the stump, and measuring the stump is, they use thermoplastic to put it on the stump, and then it takes the shape of the stump, and then you can build a mold, and then you can develop the prosthetic. Now, what I like to do is 3D scanning. I have a 3D scanner in my office, and I usually use it. So 3D scanning is actually the future for prosthetic, prosthesis. So you do the measurements. It doesn't matter which way you're using, what technology. Then measure of the body to determine the size required for the artificial limb. You create the model of the stump. I like to do simulation using software, 3D scanner, send it to the software, just like the AutoCAD, and then you try to modify stuff. Then you form the thermoplastic sheets to do the mold, and then we do the permanent socket. Different methods are used, so we can use, those are old manufacturing. Now we do 3D printing most of the time. Even though for the socket, we have very, very precise, smooth 3D printers. They can do this. Creation of metal parts of the artificial limb, we can do die casting, assembly of the entire limb, and then we give it to the subject. I know that if you are into manufacturing, you would like to go into one of these clinics that they develop or build prostheses. That's what they will be doing there. Okay, we have preparatory and definitive prostheses. They like to use these words with the physical therapist. They're temporary and definitive. Temporary prostheses fitted while the residual limb is still maturing. Preparatory prostheses allow the patient to train with the prosthetics several months earlier, result in a better fitting for the final prosthesis, and also the subject becomes, get used to actually use this prosthesis. The advantages of a temporary shrinks the residual limb. That's another important thing. If the residual limb was left without a socket, it will continue swallowing because the body is not used to it. And there's a lot of things that happen. The bone will start to degrade, and liquids will start accumulating in it, especially if it's a lower extremity. Allows earlier bipedal ambulation if it's lower extremity. Can return to work. Yep, that's important. It is a positive motivation reduced for complex exercise programs. So if someone is not using a prosthetic for 6 months, that's a big problem for us. And also, if someone can't pay for the permanent prosthesis, they can get that done. Lower limb prosthesis, we have several levels. Partial foot, it means that we are, so if it's, yep, partial foot is here, and then you have the ankle articulation, mid-shank, and all of the other names that you have on the slide, up until you have hip disarticulation. Those are all the amputations. And it depends on the surgeon and the situation of the subject of how we do this. Now, lower limb prosthesis, you will have internal parts. Now, usually they used to be one piece. Now we have internal parts and aesthetic parts. So the load-bearing parts will be those with joints, more sophistication, and then you have something to cover it on the outside. We're going to talk about also the upper limb prosthesis. Now, here's the thing. People actually, which one of these do you think people prefer the most? Yep, because of the functionality. And the things that this is a wire that is connected to the other limb, so you can control this limb with the other limb. So this two movement, the human body movement, is actually looks like something preferable by the patients, more than to have something like this, plastic. But these robotic type prostheses are becoming more and more actually common because of functionality. Now, for us as engineers, we know that we are good in problem solving. We know the engineering design process. You know something called design thinking, correct? And no matter what the problem that we are faced with, we are equipped with the knowledge that we can come up with multiple solutions. The gap that we need to bridge is the clinical tests that the physical therapists are doing in order to assess the performance of the subject. So you need to make sure that you know all of these tests. So for example, we have test 1, 2, 3, 4, 5, 6 types of tests, and you will have the test name, and then you have the parameter that the here that is assessed in each one of these tests. So for example, performance measures the 10-meter walk test. They will ask the subject to walk for 10 meters and see how much time that will take. Now, if you have a poor fitting on a lower extremity, it will take them 20 minutes and a lot of energy consumption. So even though the time is a very simple thing to measure, but actually it's very valuable for clinical and occupational therapists. Very valuable. Now, the 6-meter walk test, and this is another one for the time as well. Then we have the 2-minute walk test. That's how much distance the subject is moving in 2 minutes. That's what we're looking at. And then you have the walking transfer test. So you go timed up and go. So this is a test that the subject will be sitting on the chair. They will find the time when they go up and move, how much. And we take a lot of things for granted. If someone was with a lower or upper prosthetic, a prosthesis, standing up is a very, very complicated task for them. And then we have the L test of functional mobility. So the time will go up, the subject will go up, move 3 meters, then 90 degrees change, right, of the direction, move 7 meters, then return 7 meters, 90 degrees in 3 minutes. So that's an L-shaped movement. And we test actually the functionality. And there is a survey the physical therapist will fill about this. And then they're all basic. And actually they've been basic for a long time. And they're not changing them. This is something that can be improved. I don't think this is what we should be actually doing, especially with all these new robotic prostheses and gadgets that we are using. And then we have something amputee mobility predictor. This is also 20-item survey, and by the way, all of these are subjective. They're qualitative measures. They're not quantitative most of the time. And then you have the locomotion complexity index, activity space specific balance, and the socket comfort scores, and the ankle osteoarthritis arthritis scale. Now, see the pain, disability, they talk about the comfort scores, but they rely on the subject telling them he's comfort or she is comfortable or not. They don't use any of the load cells. So none of these tests actually use technology. And for example, see the L test, we can use the cameras and the force plates and to see the balance of the subject, not just looking at the time and all these other things. So I wanted you to have a list of them and what parameters they're using. And I wanted to show you that all of this is still very basic, qualitative measures from the subject. None of them is quantitative except time and distance. And even time and distance, they're just using very, basic tools, just like a scale or whatever, stopwatch, and yeah, that's what they use. So there's a lot of room to improve these tests. So you can work with them on develop new tests that can be useful for the clinical setting. Okay, responsiveness. After we do the initial fitting of the prosthesis, we need to make sure that it is the subject or the what do you want? Yeah, the subject and is using it, and within 48 hours of patient discharge out of the inpatient rehabilitation admission, we should get survey and feedback from the subject. And that's where a lot of things fail, actually, because people do not come back to the clinic. And then there is a 3-month outpatient follow-up, and that's it for the prosthetic. So the interaction with the physical therapist, if there are no problems, is just 2 times. So it all depends on the subject themselves. Now, people stop using them, don't go back. So the physical therapist will say that everything is okay with but that's not actually with that. And that's where we can help with something called personalized medicine, and have some sensors that can feed always. You transmit your data to the physical therapist, right? Just like the Apple Watch measure data and you continuously send the data. We can develop things for people with disability to do that. So this is a quick introduction to what we are going to get into in the coming, couple of weeks, and then we will move. I will move from passive prostheses to wheelchairs, mobility aids, and then so upper and lower extremity prostheses, then mobility aids, and then we'll go to